Hi everyone, welcome to your first revision lesson on P8. We are going to be looking at the first part of P8, which is all about car safety. Now these modules tend to recap a bit of what you already know, so that's nice and easy, but get you to use different skills. So one of the biggest skills in this module is all about estimating. So just bear in mind that what might appear easy is easy, but just remember to estimate. Think, okay, roughly how heavy is a person, roughly how heavy is a car, roughly what. Get used to doing that. If you want any practice, start thinking about lots of different objects in front of you and thinking, okay, roughly how heavy would that be? Roughly how heavy would that be? Okay, how fast if I threw it would it be? You know, my point is, throughout this module, estimating is one of those key skills. So, first bit is two equations you saw in P2, really nice and easy. Speed is distance divided by time, and acceleration is change in velocity divided by time, or v minus u over t. Speeds of the following. Walking, roughly a metre a second. So these are speeds. If you are rubbish at estimating, I thought basically I'd just give you some. Running, about 5 metres per second. Full confession, I definitely do not run at 5 metres per second, but you know, people are quicker than me. Cycling, normal people, about 7. Cycling, Olympic athlete, about 20 metres per second, incredibly quick. Car, 22 metres per second. And train, 56 metres per second. So yeah, hopefully that one's fairly straightforward. I would take a note of these if you are rubbish at estimating, because it just makes your life easy. If you're good at estimating, you don't need to remember these, then save yourself some bother. Next bit, distances, stopping distances in particular. When a car or a moving vehicle stops, here we're looking at a motorbike, the distance it takes to stop will be split into two. The first distance is the thinking distance, which is the distance a car travels in a split second between a hazard appearing and the driver applying the brakes. Now, I said this at the time, but just please be careful that if they ask you what thinking distance is, you refer to a distance. The most common mistake is for people to talk about the reaction time as opposed to the distance if you're being asked about distance. If you're being asked about time, feel free to talk about it, but you know what I'm trying to say here. The next part, I don't know whether it's going to come up actually. The next part is the braking distance. And this is the distance that you travel once the brakes are applied. So you've reacted and then you've applied the brakes. And you need to know different things that affect both of those. So thinking distance, alcohol, drugs, tiredness. They tend to actually put those three in the same bracket. So if you're thinking about things that affect the thinking distance, try to say one of those and then move on to a different category. Being distracted by people /radio/sat-nav. Eating or drinking, and speed. Speed is the only factor that affects both thinking distance and braking distance. The faster you are travelling, the further you will travel whilst you are reacting. Braking distance then. Official definition, the distance a car travels during its deceleration whilst the brakes are being applied. It is affected by speed, mass of the car, poor brakes or tyres, and the grip of the road surface. So on a wet road, you can skid twice as long. On an icy road, I think it's 8 times as long. It is incredibly long. Could be lying on that one, but it is very, very long on an icy road. There you go. So the faster the speed, the longer the braking distance. Doubling the speed quadruples the braking distance. And this was, if you remember when we did this the first time, this is actually from the highway code, and it shows typical stopping distances at different speeds, basically. So 20 miles an hour, you've got about 12 metres stopping distance. At double that, 40 miles per hour, you've got 36 metres. So yes. Right, next bit. Again, an equation from P2. V squared equals u squared plus 2as. But this time, when you're working out braking distances, you will want to rearrange it. The top version of the equation is given to you on your equation sheet. The bottom version is not. So I would suggest either knowing how you rearrange and making sure you're very good at that, or remembering it, whatever you prefer. So to find the distance, s is v squared minus u squared over 2 times acceleration. Reminder, v and u are initial and final velocity. Final and initial, I should say. Right, next equation we're using, again, you've seen this before, hopefully you're recognising all of these. Newton's second law, F equals ma. The larger the deceleration of an object in a car crash, the bigger the force exerted on it. Now, just a quick note that we are going to combine lots of different equations. Actually, we're going to be combining this one, we're going to be combining acceleration, and we're also going to be looking at momentum. Remember, momentum is mass times velocity. So here we go. I have put two equations on here. I've said force is the change in momentum over time, and force is mv minus u over t. Now, both of these have come from forces mass times acceleration. The top one, in fact, I really feel like I probably should have swapped them around. And let's look at the bottom one first. The bottom one, I've just removed acceleration and put in the equation for acceleration, v minus u over t. The top one, I've said, okay, well, mv is momentum, and mu would kind of be like initial momentum. So clearly, that top line of the bottom equation could be written as change in momentum. They all mean the same thing. It's just what are you being given, really. So just be aware, you've got to spot, you've got to try and make those connections. This is the type of thing that will lead you into A-level questions. So if you are thinking about doing A-level physics, this is the type of thing. Spot those connections. Right, and that was it. That's us really covering everything. So there are some questions to do. Let me know if you have any issues. See you soon.